Questions 11 through 20 on the 2019 Grade 10 AMC 10B. Two jars each contain the same number of marbles, and every marble is either blue or green. In jar 1, the ratio of the blue to green is 9:1. The ratio of blue to green in jar 2 is 8:1. There are 95 green marbles in all. How many more blue marbles are there in jar 1 than jar 2? So we have one jar and we have another jar. We'll call this jar 1. And this, of course, jar 2. So we have a certain number of green and a certain number of blue, and the same thing in jar number 2. So in jar number 1, the ratio of blue to green, they told me in the question, is 9:1. So that means B is equal to 9G. And I'll just call this B1 and G1, just to avoid confusion. And the second one, the ratio they told me is 8:1. So now B is equal to 8G, and this is 2 and 2, like that. Okay, and then what else do we know here? We also know that the same amount is in each jar, so that amount I don't know, so I'll just call that amount X. So there's X marbles in jar 1 and X marbles in jar 2. So in jar number 1, B1 plus G1 is equal to X. So that would mean B1 plus, well, let's put it in terms of G. I think that'll be a little bit easier. B1 is 9G1, so let's put that in. So that means 10G1 is equal to X, and therefore G1 is equal to X over 10. We'll do the exact same thing for jar number 2. That is basically B2 plus G2, and that is also equal to X. So B2 is 8G2 in this case, so 8G2 plus G2 is X. And therefore 9G2 is equal to X. G2 is equal to X over 10. All right. And then they gave us this piece of information that there's 95 green marbles in all. So G1 plus G2 is equal to 95. So in terms of X, it would be X over 10 plus X over 9 is 95. All right, great. I can solve for X now. So getting a common denominator, that's going to be 9X plus 10X over 90 is 95. So that means 90 times 95 and that's going to be equal to 19x, and therefore x is going to be equal to 90 times 95 divided by 19, which is 450. Okay, so finally we can compare the blue marbles now, since we have an analysis here. G1 is x over 10, so that's 45. G2 is x over 9, so that's 50. B1 therefore is 9 times G1, so that's 9 times 45, so that's 405. And B2 is 8 times G2, so B2 would be 400. So how many more blue marbles are there in jar 1 than jar 2? Well, you're comparing 405 to 400, so 5 is the answer. So number 11, that would be A. What is the greatest possible sum of the digits in the base 7 representation of a positive integer less than 2019? Well, in case you're not familiar with base 7, no problem. I'll give you an example. So let's say I have a number 365, and this is base 7. If it was base 10, it's just 365, but it's base 7, so it's not 365. What is it? Well, it's 3 times 7 to the power of 2, plus, in this case, 6 times 7 to the power of 1, plus 5 times 7 to the power of 0. So that would be 3 times 49, plus 6 times 7, which is 42, plus 5 times 1, which is 5. So that's what, 147 plus 47, and I believe that's 194. So as you can see, it's not 365 because it's base 7. So we have to do this big long calculation. So what they're asking for is, what is the greatest possible sum of the digits? So this is, for example, the sum of the digits here was 3 plus 6 plus 5, which is what, 14, right? So they're asking the same thing, but they want you to go up to 2019 and see what possible greatest sum you can get. Okay, well, I think I'm pretty confident that it's going to be a 4-digit number, because whatever number it is, right, you're going to take this digit, whatever it is, and multiply it by 7 to the power of 3. This will be multiplied by 7 to the power of 2, 7 to the power of 1, 7 to the power of 0. So that is sort of how we do it, just like how we did here. And what are these numbers? This is 1, this is 7, this is 49, and this is 343. And then another very important thing to mention in base 7 is that the digits can only be from 0 to 6. In base 10, the digits are from 0 to 9, but for base 7, only from 0 to 6. So the maximum I could put here is 6, 6, 6, 6, like that. And if I did, that number I can now figure out. It would be 6 times 343 plus 6 times 49 plus 6 times 7 plus 6 times 1. And when you calculate that number, you get 2400. Well, that's no good because the number's got to be less than 2019. Okay, so what that makes me think is that this cannot be a 6. It would make the number too big. I'm thinking that's going to be a 5. So let's recalculate this with the 5. Okay, so that just means I have to change one number. 5 times 343 is the only number I have to change. So this one, instead of that, it becomes 1715. And then for this sum is now 2057. Okay, well, we got lower, but it's still too big. It's still not less than 2019. All right, no problem. What that makes me think is that this 6 is not going to be a 6. We can make it a 5. And that, I think, should do it. It should bring us below the 2019 requirement. All right, so let's calculate this now. And it does. It's 2008. So perfect. So that is my number. 5566. And of course, that is to the base 7. Now they want you to figure out the sum of the digits of that. The sum of the digits would be 5 plus 5 plus 6 plus 6, and that is 22. So number 12, the answer is C. What is the sum of all real numbers x for which the median of the numbers 4, 6, 8, 17, and x is equal to the mean of those 5 numbers? All right, the mean, let's just do that first. 4 plus 6 plus 8 plus 17 plus x. And then, of course, you divide by 5. And that is what? 35 plus x divided by 5. Or if you really want to, 7 plus x over 5. Okay, now let's talk about the median. The median, I think, is going to be a little bit more work. So those numbers are fixed, but I have to figure out where the x goes. And I'm not sure where the x goes. Let's just place the x here. And in that case, x would be less than 4. So it's very important we pay attention to the parameter. And then the median, I'll squeeze in here. The median here looks like 6, because median is always the middle number, right? So let's make a little table, nothing too complicated. Okay, next is when we squeeze the x here. And in that case, x would be between 6 and 4, and the median again is 6. The next is when, well, I actually skipped one. How about when x is equal to 4? When x is equal to 4, it would be 4, 4, 6, 8, 17. The median is 6. Okay, what about when x is equal to 6? then it would be 4, 6, 6, 8, 17. The median is also 6. And then now we are going into the next category where x is between 6 and 8. So x is now between 6 and 8 like that. The median this time is x. Okay, so we got something different this time. So now we get into the next category, which is when x is equal to 8, and that would be 4, 6, 8, 8, 17. This time the median is 8. Next, 4, 6, 8, x is there, so that means x is between 8 and 17, and the median again is 8. Finally, we have x equals 17. 4, 6, 8, 17, 17. Median again is 8. And then x is greater than 17. So we'd have 4, 6, 8, 17, and x. Median again is x. 8, I should say. Okay, so it looks like we only have 3 to worry about. Either the median is 6, or it's x, or it is 8. Okay, so let's start with the first one, when the median is 6. So that means 6 is going to equal the mean. So we have 6 is equal to 7 plus x over 5. So that means negative 1 is equal to x over 5. So that means x is equal to negative 5. X is equal to negative 5. Does it fall within the range? Well, this range basically is any value of x that's less than or equal to 6. And x equals negative 5. That is within that range. Okay, so this is a good one. Let's try it now. X, that's the next median. X this time is equal to 7 plus x over 5. Okay, so that's going to be x minus x over 5. 4x over 5 is equal to 7. So 4x is equal to 35. X is equal to 35 over 4, which is what, 8.75? Yeah, 8.75. Well, the range for x there was between 6 and 8. 8.75 is not within that range. So that is no good. Inadmissible. And the reason is because it doesn't fall in that range. Okay, we got one more to do. And that next one is when the median is 8. So that means 8 is equal to 7 plus x over 5. So that means 1 is equal to x over 5, and therefore x is equal to 5. Now, in this part of the table, x was greater than or equal to 8. And x equals 5 is not greater than or equal to 8. So again, we have something that's inadmissible. So it looks like the only admissible was this guy. So that's it. What is the sum of all real numbers? Well, there's only one real number, and it's negative 5. So the sum of that is just itself, 13. The answer is A. The base 10 representation for 19 factorial is this big long number, where t, m, and h denote digits that are not given. What is t plus m plus h? Well, the first thing I'd like to talk about is how many factors of 10? Well, to get a factor of 10, what you really need is 2 and a 5, because it's 2 times 5. Well, I can easily take out 2's. Every even number will be able to give me a 2. So 2, 4, 6, 8, there's more than enough 2's that I can extract from 19 factorial. But what about the 5? I can get a 5 from the number 5. I can get a 5 from the number 10. And I can get a 5 from the number 15. So I will be able to extract at least 3 5's. This becomes 10, this becomes 10, this becomes 10. So when you multiply them all, that's 1,000. And therefore, this number ends in 3 zeros. So h00 is 0, 0, 0. So that means h is equal to 0. Now we have 2 divisibility rules. And there's numerous divisibility rules. So many, probably one for every number, perhaps. I don't know, but I've definitely seen many. But I'm only going to concentrate on two of them. The one is for 9s and the other is for 11. The 9 is the one that's commonly used in a math contest, that if a number is divisible by 9, the sum of the digits is also divisible by 9. Well, this number is definitely divisible by 9 because it's 19 factorial, and one of those numbers in 19 factorial will be a 9, right? 19 times 18 times 17 times 16, all the way down to 9 times 8, so on. So that number, the sum of the digits, must be divisible by 9 since the number is divisible by 9. So add up all these guys, and when you do, you get 33 plus t plus m plus h when I added up the digits, and that has to be some multiple of 9. If a number is divisible by 9, the sum of its digits is divisible by 9. Well, h we know is 0, so I don't need to worry about that. So I just have to look at t plus m is equal to 9k. Well, what are some multiples of 9 that would make sense? Because t and m have to be positive digits, right? It's got to be obviously greater than 33, so a 36 would make sense, and then 45. Anything greater than that, it's not going to work for t and m because t and m will no longer be digits. They have to be single digits between 0 and 9. Okay, well, if it's 36, that means that 33 plus t plus m is 36. So that means t plus m is equal to 3. If it's 45, then that means 33 plus t plus m would be 45, so t plus m would be 12. Well, both of those are answer choices, so they're not making it that easy for us. We got to eliminate which one of those. Well, we can eliminate these guys. Now it's down to 3 and 12. The next divisibility rule is the one that's going to help us. That is as follows. For 11, the divisibility rule is that if a number is divisible by 11, then the alternating sum is also divisible by 11. This number is clearly divisible by 11 since it's equal to 19 factorial, and 11 is part of 19 factorial. But what do I mean by alternating sum? Well, look at this number closely, and look at the digits. The digits are 1, 2, 1, 6, t, 5, 1, 0, 0, 4, 0, m, 8, 3, 2h, 0, 0. Alternating sum is you alternate. So plus minus, 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 plus minus. That's what they mean. Okay, and that has to be equal to some multiple of 11. So 11k. So when you do that whole math, you basically get t minus m minus 7. And remember, h is 0. All right, so as we did above, let's figure out what kind of scenario would be able to help us get some values for t and m. Okay, it could be 11, t minus m minus 7. And if it is, that means t minus m would be 18. Okay, t minus m is 18. Let's see if it works. If I take the t plus m is equal to 3, and then I add these two, I will get 2m is equal to 21. And m is not going to be an integer, so that's no good. Let's keep that 18 and t minus m, and then now let's work with that one. T plus m is equal to 12. This gives me 2t is equal to 30. T is 15. It works in terms of an integer, but t has to be a digit. Remember, it has to be a digit between 0 and 9. Okay, so that didn't work. No problem. Let's try another multiple of k, or 11, I should say. Well, what else can I try here? Maybe 0? I think 0 would work, wouldn't it? Or I can try minus 11. It's up to you, trial and error. Let's try minus 11. T minus m minus 7 would be minus 11. So that means t minus m would be add 7 to both sides, negative 4. Okay, just as I did before, let's see what happens with t plus m is equal to 3. If I add those two, I get 2t is equal to negative 1. Well, 2t equals to negative 1, that doesn't work as an integer. Okay, no problem. Let's try negative 4 is equal to t minus m with this guy. Let's see if that works. And I hope it does. So that means 12 is equal to t plus m. that means 2t is equal to 8, t is equal to 4. And substituting that back into here, I will get m equals to 8. Okay, that definitely works. So t is 4, m is 8, h is 0, so that means t plus m plus h is 12. So that's a pretty cool question. So number 14, the answer is C. Triangles that are right T1 and T2 have areas 1 and 2 respectively. A side of T1 is congruent to the side of T2, and a different side of T1 is congruent to a side of T2. What is the square of the product of the lengths of the other third sides of T1 and T2? I'll just draw some very basic diagrams, not necessarily drawn to scale. So here's, let's say, my first triangle, and the second one obviously it's got to be a little bit taller, and I'll just make it like that. So now let's talk about what they're asking for in the question. These are right triangles, and a side of T1, this is T1, and this is T2. I'll just say this side is congruent to a side of T2, so I might as well say that's also B. So this is the same as that. Then a different side of T1, obviously it can't be this one and that one, because if it did, that would make those triangles the same. And because they have different areas, they can't be exactly the same in terms of the sizes. So I'm going to say that this side is something I'll choose, and it will be the same as this side. I think that would make much more sense. And now let's label the third side. I'll call this X, I'll call this Y. So what are they asking for? They're asking for the square of the product of the lengths of the other sides. So basically what they're saying is find the square of the product. The product is x times y, and then the square. So that is going to be x squared, y squared. So this is essentially what we have to find. Okay, I think I can do that. Let's see here. The area is 1 here, and the area is 2 here. So immediately, because they're right, we can use 1/2 base times height is equal to 1. So that gives me that b is equal to 2 over x. And the same thing here, 1/2 base times height is equal to 2. So that gives me that b is equal to 4 over h. And I can set these equal to each other and get another relationship, which may help me. This will give me that 2h is equal to 4x, or h is equal to 2x. Okay? And then now, using Pythagoras, I'll get a couple more relationship. The first one is x squared plus b squared is equal to h squared. And the second one would give me that h squared plus b squared is equal to y squared, like that. All right, well, I think I can get a numerical value for x, because in this equation here, x squared plus b squared is equal to h squared. I can substitute b in terms of x and h in terms of x. So it's x squared plus b squared, which is 2 over x squared, and then h squared, which is right here, 2x. So that would be 2x all squared. So x squared plus 4 over x squared is equal to 4x squared. So that means 4 over x squared is equal to 3x squared. And therefore 4 is going to be equal to, 4 over 3 is going to be equal to x to the power of 4. Okay. That is, gives me a numerical value for x to the 4th, at least. Okay, so I think I am ready to figure out what they want me to, which is this guy right here. And we do that as follows. I noticed that both of these guys are represented here. X squared is here and y squared is here. So if I can combine those, I think I can do it. So x squared from this would basically be h squared minus b squared. So that's x squared. And then y squared from here is just h squared plus b squared. And that's y squared. So that is equal to that. Okay, so let's see what happens. When you expand, you get h to the power of 4. And then the second and third term cancel, minus b to the power of 4. Okay, Well, okay, I see now. I can substitute this. So h is 2x, so that's going to be 2x to the power of 4. B is 2 over x, so that's going to be 2 over x to the power of 4. So that gives me, what, 16 x to the power of 4 minus 16 over x to the power of 4. Okay, so that's where that x to the power of 4 comes in handy. All right, so that's just going to be 16 times 4 over 3 minus 16 over 4 over 3. Okay, so at this point, you definitely know how to do this. And that's just crunching numbers now. And when you do, you get 28 over 3 at the very end. So number 15, the answer is A. In triangle ABC with a right angle at C, point D lies in the interior of AB, and point E lies in the interior of BC, so that AC is equal to CD, DE is equal to EB, and the ratio AC to DE is 4:3. What is the ratio AD to DB? The first step, of course, is we've got to draw at least some sort of a diagram that helps us. Doesn't have to be perfectly drawn to scale, but it should at least give us some idea of how to do this. So I'm going to attempt to draw something that looks somewhat reasonable, and if it's not perfectly drawn to scale, not a big deal. Okay, and then I'll draw two altitudes, one here and one here, like that. These are altitudes that meet at right angles. Okay, so let's start labeling this. This is A, B, and C, and it is a right angle right here. That is a right angle. And then they tell me that we have D right here and we have E right here. And then they've given some ratios, and with those ratios I can label this 4x, and this is also 4x since AC is equal to CD. And then with the ratios with the DE equals EB, and then this ratio that it's 3, that's going to be 3x. So this is 3x and this is 3x. All right. Now we have to do a little bit of angle chasing, not too much. If I label this angle, say theta 1, and this theta 2, this is 90 degrees right here. So that means theta 1 plus theta 2 plus 90 equals 180. So that means theta 1 plus theta 2 is equal to 90. Okay, now this is an isosceles triangle right here, since 4x and 4x are the two sides. So that means this is theta 1 also, that angle. Very similarly, that's an isosceles triangle. So this angle is theta 2. So since theta 1 plus theta 2 is equal to 90, then that means this angle has to be 90, because all of those angles have to add up to 180. So that means that is a right angle. If this is 4x and this is 3x, then I'm sure you can figure out what is that. Hypotenuse. It's a 3, 4, 5 triangle. So that's a 5x right there. All right, so I think we're ready to figure out this ratio AD to DB. So they want AD to DB. Okay. So we're going to do that by just looking at this triangle, this right triangle right there. In that triangle, the hypotenuse, 3 over 8, meaning from here to here over the full, which is essentially the same as writing BE over BC. That is the same as the bases, since if you look at it from a similar triangle's perspective. So it'll be the same as from there to there over from there to there. And I'll just label this. We'll call this G and we'll call this F. So it's the same as BG over BF. Well, BG is a half of BD, because in an isosceles triangle that would chop the side in half. And then BF all the way there would be BD plus a half of AD, which is FD. like that. And then I'll just multiply top and bottom by 2 just to get rid of the fractions. So it would be BD over 2BD plus AD. Okay, so that is equal to 3 over 8. So let's cross multiply. So 8 times BD would be equal to 6BD plus 3AD. So that means 2BD is equal to 3AD. And therefore AD over BD would be equal to 2 over 3. And there you have it. AD to DB, or BD, DB, same thing, is 2 to 3. So number 16, the answer is A. A red ball and green ball are randomly and independently tossed into bins numbered with positive integers so that for each ball, the probability that it is tossed into bin K is 2 to the minus K for K equals 1, 2, 3, ... What is the probability that the red ball is tossed into a higher numbered bin than the green ball? All right, so we have some bins here, and I'll just draw the first few, and they're labeled. So this is K equals 1, K equals 2, and so on, K equals 3, K equals 4, and that just keeps on going, right? And we have two balls. We have a red and a green, and the probability that it goes into each of these is given by this formula, 2 over minus K. So in this case, the probability would be 1 over 2. Here it would be 1 over 4. Here the probability would be 1 over 8, 1 over 16, and so on, right? Just ... just keeps on going like that. So we want the red ball to be placed in a higher numbered bin than the green ball. Okay, so what I'll do is I'll make a little table, and let's talk about this. So we have green, red, and then the probability. So the placement of the green ball, then the red ball, and then the probability. Well, if the green ball is placed into the bin that's called K equals 1, the first one, then the red ball can go into any of the other ones. So any of the other ones except K equals 1. Because remember, we want the red ball to be put in a higher numbered bin than the green ball. Okay, so what's the probability, first of all, that the green ball goes into K equals 1? Well, that's a half. So it's a half. And then we have to multiply that by the probability that the red goes into any one except the K equals 1. Well, that's just going to be 1 minus a half. We can put it in any one of these, but it can't go in here. So the total probability is 1, so we just have to subtract that guy. Okay, so that looks like 1/2 times a half, which is a quarter. All right, let's keep going here. So I think I will do, I'll do 4. I think that should be good enough to see the pattern. Okay, K equals 2. If we want the rule to hold, R can go into any except it can't go into K equals 1 or K equals 2. So the probability that we put G into K equals 2 is a quarter. So that goes here. And then multiply this by all of these, which would be 1 minus this and this. So 1 minus a half minus a quarter. And that, I believe, is a quarter. So this is going to be a quarter times a quarter, which is 1 over 16. All right, let's keep going. K equals 3. Again, it can be in any except K equals 1, 2, or 3 in order for this rule to hold, that the red ball is tossed into a higher numbered bin than green ball. Okay, probability that G goes into K equals 3 is 1/8. So that goes there. And then the probability that R goes into any except 1, 2, 3. So 1 minus these 3. So 1 minus a half minus a quarter minus 1/8. And that number here is 1/8 when you do those fractions. So it's 1/8 times 1/8. and that is 1 over 64. Okay, some of you probably have the pattern figured out, but in case you don't, we'll just do one more. If it goes into k equals 4, the green one, then r has to go into any, but it cannot go into k equals 1, 2, 3, or 4. All right, so that means probability that g goes into k equals 4 is 1 over 16. And then again, we have to multiply by 1 minus a half, minus a quarter, minus an eighth, minus a 16th. And that is 1 over 16, this whole thing, when you do the math. So it's 1 over 16 times 1 over 16, which is 1 over 256. Okay, so I think you get the point here. The probabilities, you have to add them all up, right? And it just keeps on going forever. So the total probability is going to be a quarter plus 1/16 plus 1 over 64 plus 1 over 256, and then it just keeps on going. So this is what is known as an infinite geometric series. And the good news is that there's a formula for that. A over 1 minus r, where a is the first term, and r is the common ratio. So in this question, what is the first term and what is the common ratio? So that means my total probability. A, well, first term is a quarter, so that's A. Common ratio you can get by taking the second term and dividing by the first term. And when you do that, you get a quarter. So the common ratio is a quarter. All right, so this looks like a quarter over 3 over 4. Invert and multiply, and you get 4 over 3, and that is just 1 over 3. So the answer to this question, number 17, is C. Henry decides one morning to do a workout, and he walks 3/4 of the way from his home to this gym. The gym is 2 kilometers away from Henry's home. At that point, he challenges his mind and walks 3/4 of the way from where he is back toward home. When he reaches that point, he changes his mind again and walks 3/4 of the distance from there back toward the gym. If Henry keeps changing his mind when he has walked 3/4 of the distance toward either the gym or home from the point where he had last changed his mind, he will get very close to walking back and forth between a point A kilometers from home and a point B kilometers from home. What is A minus B? Well, this question takes a little bit of thinking about exactly where do we place everything. So let's just say this is home at the other end, and at the opposite end is the gym. And because of the symmetry of this diagram, the points A and B are going to be equidistant from either end. So for example, let's just say if this is A, and the distance from A to home is, say, X, and this is B, then the distance from B to the gym will also be X. So now we have to think about this. We're going to label a bunch of stuff here. This distance between A and B, since the total distance is 2 kilometers, it's going to be 2 minus 2x. So if he's at B and then he starts walking this way, he only walks 3/4 of the distance. 3/4 of the distance from B back home. So that means this 2 minus 2x represents 3/4 of the distance from B all the way back home. And the distance from B all the way back home from there to there is 2 minus x. So that is what you put here. And that basically is the question. Much more simpler than I had originally thought. It takes a little bit of confidence and understanding of the symmetry of the problem. Okay, so I think I can solve that. At least I hope. So that's going to be 8 minus 8x is 6 minus 3x. So that means 2 is equal to 5x, and therefore x is equal to 2 over 5. So point A looks like it's 2 over 5, since that's x. And then x, point B, would actually be 2 minus x, right? Since this is sort of a continuum. So 2 minus x would be 2 minus 2 over 5, which is 8 over 5. So that's 8 over 5. So now they basically want a minus b, so that would be 2 over 5 minus 8 over 5, and then the absolute value. So that's minus 6 over 5 absolute value, which is just 6 over 5. And 6 over 5 is the equivalent of 1 1/5. And therefore, number 18 would be C. Let S be the set of all positive integers divisors of 100,000. How many numbers are the product of two distinct elements of S? Well, 100,000, as I'm sure you know, is 10 to the power of 5. And you can break down that 5 into 2 times, you can break down that 10 into 2 times 5, and therefore it becomes 2 to the power of 5 times 5 to the power of 5. So if we take any number that is a divisor, it would be of the form 2 to the power of A times 5 to the power of B, where A is anywhere between 0 and 5, and B is between 0 and 5. These would be the divisors, any number of that form, where A is between 0 and 5 and B is between 0 and 5. Okay, so we take two distinct of those elements. So if I take two distinct, it would be, the first one I'll call it A1 times 5 to the B1. And then I'm taking a product, so it would be, the next one would be distinct, so it's going to be another A1 and A2. So let's just say 2A2 times 5B2, like that. Now if you combine these, it'll be 2A1 plus A2 as the power times 5B1 plus B2. And A1 plus A2, if you look at this right here, the minimum it could be is 0, and the maximum it could be is 10, right? And same thing with B1 plus B2, the minimum and maximum are 0 and 10. So the number of possible values for A1, A2 look like 11, 0, 1, 2, all the way up to 10. So we have 11 possible values for this. And the number of possible values for B1, B2 are also 11, 0, 1, 2, 3, all the way up until 10. So the number of possible values would be 11 times 11, which is 121. And that is one of the answers. But AMC always likes to, be a little tricky. There's always, not always, but sometimes there's some overcounting, inadmissible values, things like that. And in this case, there's 4 values that are inadmissible. And therefore, you'd have to subtract those 4, and that would bring you to 117. But let me explain what those 4 are. The key word in this question is distinct. And there's 4 times where you don't get distinct. And those are as follows. The first is when A1 plus A2 is 0, and B1 plus B2 is also 0. If that is the case, you would basically get 2 to the power of 0 times 5 to the power of 0, which is basically 1 times 1. 1 and 1 are not distinct. You have to have 2 different terms. And since 1 and 1 are the same term, that is inadmissible. The other scenario is when you have 0 and 10. This becomes just 2 to the power of 0. This is 5 to the power of 10, which is going to be just 5 to the power of 10, right? But how did you get 5 to the power of 10? You can't get that with one term because b can only go up to 5. So you must have done a 5 to the power of 5 times a 5 to the power of 5. That's the only way you could have gotten 5 to the power of 10. But if you did, you have two of the same elements. So again, for the same reason, inadmissible. Another inadmissible is the 10-0. Very similar reasoning. Here we have 2 to the 10, 5 to the 0. Well, 5 to the 0 is just 1, so that's just 2 to the 10. How did you get 2 to the 10? It'd be 2 to the power of 5 times 2 to the power of 5. These are the same. They have to be distinct. And the last one is when you have 10 and 10. So 10 and 10 is basically 2 to the power of 10 times 5 to the power of 10. Now, the only way that could have happened is if you had 2 to the power of 5 times 2 to the power of 5 times 5 to the power of 5 times 5 to the power of 5. And one combination of this would be combining this with that. So it would be 10 to the power of 5 times 10 to the power of 5. And again, those are the same. They are not distinct. So these 4, 1, 2, 3, 4 scenarios have to be subtracted from the 121, and when you do, you get 117. So number 19, the answer is C. As shown in the figure, line segment AD is trisected by points B and C so that AB equals BC equals CD equals 2. 3 semicircles of radius 1, arc AEB, arc BFC, and arc CGD have their diameters on AD, lie in the same half plane determined by line AD, and are tangent to line EG at E, F, and G respectively. A circle of radius 2 has its center at F. The area of the region inside the circle but outside the 3 semicircles shaded in the figure can be expressed in the form A over B times pi minus root C plus D, where A, B, and C are positive integers and A and B are relatively prime. What is A plus B plus C plus D? A few very helpful lines I will draw. The first one is right across like that. The next one is right down like this. And the third line is on the other side like that. Now, we have to figure out this area. I won't shade it in. I'll just write a perimeter around it like that. That is what we have to figure out. So how do we do that? I'm going to break it up into 3 sections. The first section is this top, which is essentially a semicircle. The next section is that bottom, and the final section are these areas right here. If I can figure out the area of those 3 sections, I will have solved the question. So let's first just figure out the top one, that one right there. That is probably the easiest one. I'll just write top here because that's just a semicircle. So it's pi r squared divided by 2. And r is 2, since that is the radius of the big circle. So that's just going to be pi 2 squared over 2, and that is just 2 pi. So I can just put that in there, 2 pi right there. Okay, the next one is going to be the sections right here. These ones in the middle, like that. Those ones I can figure out fairly easily. How though? Well, take this full rectangle and then subtract from it 1, 2, 3, and 4 quarter circles. So that would be able to figure out that shaded region. Okay, so that, whatever you want to call it, we'll just call it middle. It's going to be the area of that rectangle. This is 1 and this is 1, 1, 1, 1. So 1 times 4. is the area of that rectangle. And then we want to subtract from it 4 quarter circles. 4 quarter circles, so 4 times pi r squared divided by 4, which essentially is just 1 full circle. So this is really just 4 minus pi r squared. And r, in the case of those smaller circles, is just 1. So this is just 4 minus pi. All right, so I got that. Now the final segment is this segment right here. That one I think poses the biggest challenge, but it's not so bad. I'm going to draw some lines now. One that goes straight down, and then one that goes from F to that point right there. And I'm going to label this. So this is 1. This from here to here is the radius of the large circle, so that's 2. And this is a right angle. So as you can clearly see, you can use Pythagoras to figure out that length very quickly. It would be root 3 from here to here. So that means this is a 30, 60, 90 triangle. And this is obviously 90 degrees. So therefore this is the 60 right here, 60 degrees right there. So to figure out the area of this section, which would be half of what we want, it would basically be the area of that pi segment minus this triangle. So I'll just call this right here, whatever you want to call it, let's just call it A. So A would essentially be the pi minus the triangle. So the pi is 60 degrees, very important because it gives me how much of the circle, 60 over 360, namely, of the area of the circle, which is pi r squared, and r is 2. And then that triangle is easy, 1/2 base times height. The base is root 3, the height is 1. So this looks like 4 pi over 6 minus root 3 over 2. And of course, this whole thing is not A, it's 2A, because A just represented half of it. So now I have to get 2A. So 2A would basically be 4 pi over 3 minus root 3. Okay, so now we're done. We can now figure out the total area of the shaded region. That total area is going to be this 2 pi plus this 4 minus pi and this 4 pi over 3 minus root 3, like that. And when you add up all these guys, 2 pi plus 4 minus pi plus 4 pi over 3 minus root 3, you get 7 pi over 3 minus root 3 plus 4. And that is of this form. As you can clearly see, it is in that form a over b pi minus root c plus d. So that means that my a is equal to 7, my b is equal to 3, my c is 3, and my d is 4. And they want me to find a plus b plus d plus c. So just add up those guys, and when you do, you get 17. 17 is the answer to this excellent question. Number 20, the answer is E.